Dear listeners, I will discuss about the wave function. From the diffraction of electrons observed in Davison-Germer experiment, de Broglie gave us a revolutionary concept. The concept is, to every moving particle there is a wave associated with it. This is called matter wave or de Broglie wave. In water waves, the displacements of water molecules change periodically in succession. In sound waves, the displacements of the particles of the medium through which sound wave passes change also periodically in succession. The displacement y equal to a sin omega t minus kx. It is a periodic function of time and space. In light waves, the electric field and the magnetic field change periodically. Electric field E equal to A or E naught sin omega t minus kx. Magnetic field B equal to B naught sin omega t minus kx. E naught is the maximum electric field, B naught is the maximum magnetic field. These are also periodic function of time and space. Then we may say, what is it that varies periodically in case of matter waves? The quantity whose periodic variations make up matter waves is called the wave function. It is denoted by psi. The value of the wave function psi associated with the moving particle at a point P x, y, z at a time t is related to the likelihood of finding the particle there at that time t. The wave function psi is a complex function. It has no direct physical meaning. It is not observable, and it cannot be interpreted by an experiment. Psi is related to the probability of finding the associated particle at a point at the time at the instant considered. The amplitude of a wave may be positive or negative, but the negative probability is meaningless. Psi star, product of psi star, complex function psi and its complex conjugate is real and positive. It may be the measure of probability of finding the particle at a point at the instant considered. And psi star is the probability density. That is, psi star is the probability of finding the particle in unit volume or in unit distance in one-dimensional case at a point P, x, y, z at the time considered. Integration psi star dv is the probability of finding the particle in a volume V, and integration psi star dx is the probability of finding the particle within a length x. If integration psi star dv is 0, then we may say that the particle is absent in a volume V. And if it is 1, then we may say that the particle is present there. Integration psi star dv equal to 0.2. It means that there is a 20% chance of finding the particle there at the instant considered within the volume V. Now we write psi equal to a e to the power minus I omega t minus kx, which is equal to a e to the power minus I omega equal to twice pi nu t minus twice pi by lambda into x, which is equal to a e to the power minus twice pi I nu t minus x by lambda. Now E equal to h nu and h by 2 pi equal to cut h. Therefore, h equal to twice pi cut h. So, twice pi cut h nu. Therefore, nu equal to E by twice pi cut h. De Broglie wavelength lambda equal to h by p. H equal to twice pi cut h divided by p. Putting these values of nu and lambda in the expression of psi, we have a equal to e to the power minus twice pi I et divided by twice pi cut h minus px by twice pi cut h, and which is equal to a e to the power minus I by cut h et minus px, which is the suitable form of the wave function. Wave function psi equal to a e to the power minus I by cut h into et minus px. It is the final form and suitable form of the wave function. According to Bragg, the pioneer in X-ray diffraction, Everything in the future is a wave, and everything in the past is a particle. Thank you.